We're already a minute over. Let's turn it over to the main people here, Monty and Prudence. Take it over for tonight's show.
Thank you, Sean. It's great to see everybody. I just love tuning into this big stream of folks every Wednesday. My name's Monty Paulson. I lead the Passivhaus team here at RDH Building Science in Vancouver. I'd like to ask you all to turn on your cameras and turn off your microphones. I'd like to thank Passivhaus Accelerator for hosting this very important party. And I'd like to begin with a toast. Cheers. We have a great lineup tonight. We have a quick video of the Blenheim Passivhaus here in Vancouver. We have a presentation by Ed May from his off Broadway location. He's going to present on a new building in the first part of the evening, and then in the second part, the after party, he's going to present a really interesting concept about jig software to make some of our tools work better together. Now let me introduce my co-host, Prudence Ferreira.
Welcome everyone to the 9th Global Passivhaus Happy Hour. Can you guys hear me? All right. On behalf of the entire Passivhaus community, I'd like to give a special welcome to any newcomers. I'm Prudence, as Monty has said, and I've been making my living from Passivhaus consulting and instructing certified Passivhaus consultants since 2009 and lead the Passivhaus team at Morrison Hershfield. And I'm very grateful to be able to say that even in these uncertain times, Passivhaus is still paying the bills. Many of you joining have Passivhaus projects that you're working on or that you live in. And we're a friendly bunch, so we'd like to invite ourselves over to get nerdy. In these trying times, getting nerdy together is the best medicine. So please make us a 2 to 3 minute video and we'll show it so we can all get inspired and invigorated. Tonight, we get to have a tour of the Blenheim Passivhaus in Vancouver's West Side. Architect Ian Robertson and Pierre-Andre Santine of Mizu Passivhaus Consulting work closely together with builder Eric Olofsson on this 3,200 square foot retrofit that's currently under construction and scheduled for completion and certification later this year. And this one is extra fun. It's got a long span mass timber concrete composite floor structure that lets the ground level space flow freely from the front yard right onto the back. Let's check it out.
This is the Blenheim Passivhaus that is being built by Eric Olofsson and was designed by Ian Robertson. You gotta love the north face with some big windows and some little ones, as well as all the street signage that was installed to teach the neighbors and the industry folk. Here is a window and wall detail. You can see the thick wall that is comprised of a SIP panel and an EFIS system, and high performance windows by Fenster that are all wood. Here is the south facing window. Look at that big slider, and also look at that ceiling, mass timber. I'm in the master bedroom and want to showcase this interesting walk-in closet, but look above, a motorized high performance window and a Daikin mini split heat pump. Here is the other side of the master, and look at small windows and a Passivhaus. They made it work. I'm on the south facing upper deck where 2 bedrooms have access to this deck, and check out on the door that threshold. The balcony space was wrapped in vacuum insulated panels so you could get this low profile step out. Here is the mechanical closet with 2 big sand and hot water tanks and one of the Zender units. This closet is definitely a challenge for the mechanical team, and everything is snug as a bug. Still in the finishing stages, but you can see how there's a lot of mass timber exposed in this place. Okay, this isn't Passivhaus related. This is all about embodied carbon. Check out the NLT floor, mass plywood, stairs and wall, and the glulam beam. Lots of wood. Here is the south facing with the big windows that I showed you from the inside. That is probably the biggest sliding door you'll ever see. Then you've got the retractable awning that'll pop out in the summertime to give the backyard a lot of proper shading. And look at that upper deck that I just showcased a few seconds ago. One of the biggest Passivhaus sliding doors you'll ever see. Hope you enjoyed the tour. Not your average Passivhaus.
That was great. Thanks so much to Sean for pedaling over there and giving us a tour.
Thanks, Sean. Thank you again for proving that pretty much anybody can make a video, and we really invite all of you to consider making your own 2-minute video. Just like that, an iPhone's all you need of Passivhaus near you. Now, we've noticed more than a few new faces on these calls these past few weeks. We're really honored that you've taken time out of your busy evenings to join us. We're working to make the Passivhaus Happy Hour a place that welcomes newcomers and helps you figure out how to learn more about Passivhaus, whatever type of Passivhaus you're looking for. If you are new, you may have noticed this is a very open source community and sometimes a confusing one. I advise you to kind of get used to it and also to ask for help. There's a lot of friendly people here on this call. And to facilitate everybody meeting 1 or 2 other people they might not already know, Zach is going to throw us into breakout rooms for about 2-3 minutes. Is that right, Zach?
Yes, that's right. And we'll just have a time for rapid fire introductions. So here you go. I think everyone's back. So is that better? Is that clearer?
Yeah.
Okay. All right. Well, so we've got some great announcements here about beginning with videos, and you already heard the plug from Prudence. We'd love to get a hold of more 2-minute videos from you guys of your projects, and there's a URL there. I'm gonna copy and paste all of the announcements into chat, so you don't have to worry about the URLs. But the other one that's coming up, video related, is that North American Passivhaus Network is holding a virtual building tour competition leading up to their conference, the virtual conference. And so entries are due on May 29th. And we've got a little article on the Passivhaus Accelerator site about that. So that's number 2. Number 3, Dr. Wolfgang Feist will be holding a press conference on May 19th called Building the Future Sustainably. And he'll be talking about Passivhaus and COVID-19 and sustainable development and climate. So if you know of any media, we'd love to get the word out to as many journalists as possible about that. FIAS is doing online training now, introducing, I think, the full trainings online, both for CPHC and for CPHB, so consultants and builders trainings. And we've got, and those start in June, and there's a link there to learn more. And then I mentioned last week, New Gravity Housing, fantastic conference is going online August 6th and 7th, and their call for proposals closes on May 22nd. And finally, a plug for pattern language from the Pattern Language from Passivhaus workshop that's being led by Monty Paulson. That starts on May 19th, and ZebX has information for registration. And last but not least, I want to thank our sponsors, our founding sponsors, Mitsubishi Electric, Zola Windows, and RDH Building Science for their support and making our work possible, as well as patron sponsors, Morrison Hirschfield and 475 High Performance Building Supply. And with that, I will hand it off.
Thanks, Zach. It is my absolute pleasure to introduce Ed May. Ed is a partner in the consulting firm BLDGtyp, based in Brooklyn. Both he and his partner John are certified both in the Passivhaus Institute and Passivhaus Institute of the US to design and consult on Passivhaus projects. Now here's the thing. Most of us on this call fall in one of 3 categories. Some of us are architects. We know how to draw buildings. Some of us are builders. We could actually create a building and work with our hands. And few of us, like myself, are geeks who can model and do policy, but couldn't either draw or build a building. Ed is that rare combination, that rare individual who is all 3. He is a builder, an architect, and as you'll see, quite a geek. I believe in the Big Apple, they call that a triple threat. And so here from his off Broadway studio is Ed May.
Woo. Thank you very much for that nice intro, Monty. I really appreciate that. Welcome to everyone who's new. It's great to see everyone. I'm going to share my screen. So give me 1 second and I'll see if I can share my screen here and see if I don't wreck anything when I do that.
Ed, there's no way you'll wreck anything.
You say that. You watch me go. How's that? Can anybody see that? Or just me?
Looks good.
Looks
Looks
great.
good. Fantastic. Wonderful.
Works
So,
well, Ed.
So first of all, thank you so much to the Passivhaus Accelerator team and Monty and Prudence for putting this on. This is such a cool event. I mean, what a weird thing to have 200 Passivhaus dorks from around the world all together on a call for a couple hours. I mean, what a great thing. What a great opportunity. So first of all, thank you guys for putting this together. I know it's a lot of work, and we really appreciate it. It's an important thing during this kind of time, and it's really, really valuable. And then just thank you for inviting me to come in and talk about some of our projects here. It's super exciting to be here with you guys today. So I'm going to talk just for a few minutes. I'm going to try and keep this to like 10-15 minutes. I'm going to talk about a project that we completed last year called the Candela Lofts. This was a really interesting project for us in our office. This was one of the first of our larger multifamily projects, and it was certainly the first commercial development project. So myself and John Mitchell work in BLDGtyp. We're Passivhaus consultants. We were partnered on this with Nastasi Architects. We had the great fortune to work with John Nastasi and his team, amazing architects, to work on this, and Bijou Partners as well. I think Matt Testa from the developers are here, so hold your hard questions for him and ask him in the after portion here.
Thanks,
So
Ed.
we're the Passivhaus consultants on this, and happy to share this project with you guys here. So this is the project. It's a commercial infill development in Hoboken, New Jersey, 7 stories, multifamily condominium, commercial development to the PHI classic standard. This was a long project in development. We completed it last year, but it was started in about 2013. So this was a long time coming on this particular one. Very nice project though. It was a really fun one to work on. You see the styling is really contemporary. As I said, John Nastasi and his team did an amazing job on the architecture and the construction management. They were really a great team to work with, a really talented bunch. We've had the privilege to work with John for many years. Really great to work with him and Matt and his whole team there at Bijou Partners as well. So nice project. As I said, a condominium, so for sale, a commercial, speculative development. This was an experiment for, I think, everybody on the team. Nobody was sure if speculative commercial property development to the Passivhaus standard would fly. It's not really a thing that there's much of in New York, at least. So this was a real experiment. The developers and the architecture team really put themselves out there on this one, and I really commend them for that. So it's a fun project, and like I said, a real experiment. For the geeks, this was to the PHI Classic certification. We started this so long ago that it was actually certified to the old PE certification. If that means anything to you, you'll understand what that means. We met the 15 kilowatt hour per square meter heating demand limit, the 17 for the cooling and dehumidification demand limit, and 102 for the PE demand. So this was so long ago that we didn't even consider the PER, although we would probably do that now if we were working on it. Something like R40 walls, R50 roof, R40 floor for this building in order to get us to that level. The density obviously really helps. That said, there were a lot of challenges on this particular building. Start with the climate. So this is a project in Hoboken, New Jersey, right across the water from Lower Manhattan, a really dense urban neighborhood, and a lot of challenges on the climate front. A place like New York, we have to wrestle with all of our heating demand, heating energy, obviously, cold winters, but also a lot of cooling and a lot of dehumidification. So a real challenge when it came to the systems and the overall building design, a really challenging climate to build in for sure. In addition, it's, as I said, an urban infill project, and it was a really not ideal site in many ways, but that's not really surprising. It's an urban infill project. The site is the site, and it was in many ways pointing the wrong direction from the get-go. So it's a north and east facing property. So we have street front north and east facing. We have a long lot line on the west side, and then not very much exposure on the south side, a neighbor to the south there, a really tight urban neighborhood to be building in. Really, really difficult spot, I think, for sure. So difficult from the engineering side and certainly difficult from the construction side. But again, they did a great job of it. From the outset, one of the main challenges on this one was that the building was, let's call it compactness challenged. All for good reason. It's contextual zoning and lifted up off the grade for flood reasons, and holding the street front and zoning, and there's all sorts of reasons why the building is the way it is. But anybody who knows what a passive house looks like, you know that a passive house prioritizes compactness, and that's not a very compact building. We were completely exposed on the underside because of the parkade, because we were lifted up off the ground. Again, all for good reason, all with completely good reasons, but very challenging from an overall massing and shape, form perspective, for sure. In fact, I think, I counted this the other day, we were up to 14 corners per floor. I'm not certain, but I think there's got to be some sort of AIA award for number of corners per floor. I hope John Nastasi's on the call here. Good-natured ribbing there. You know, obviously a nice project, but very challenging, again, from a compactness and a construction standpoint there, for sure. But really, the biggest challenge on this building, the main thing that we were struggling against from the very beginning, was exactly how this building was built. As I said, it's commercial property development in the New York metro region. It's built from steel stud, concrete floor slab, gypsum siding, or gypsum sheathing. It's built in a really challenging climate under really difficult conditions, a dense, narrow lot. This was a very difficult project to manage, as I've said many times now. So how did we do it? How did it get put together? Well, overall, or I guess I should just say overall, in fact, what we found when we crunched the numbers was that the thermal bridge losses alone on this building, because of the way it was built, because of the steel studs and the concrete and the footings and the parapets and everything else, were responsible for probably like a 10% increase in overall heat loss. That's after we worked really hard to optimize and improve and manage, make sure that we had all our surface temperatures in the right place and moisture resistance. And so just the nature of the type of construction here, steel stud, concrete floor slab, masonry, it makes it very difficult to achieve those traditional passive house limits. So again, how did we do it? Well, this building uses a really simple strategy. We just took the base building, steel stud and concrete floor slab, and we wrapped it in a thick wool jacket or a thick wool sweater. That's all we did. There's really no more magic than that. In this case, it happened to be about 8 inches of mineral wool that we wrapped the entire building in as a thick sweater. Here we used low conductivity facade clips made from a fiberglass material so that we get very low thermal bridging through that. And you can see we hold those steel stud girts out away from the facade. It allows us to get that continuous 8 inches of mineral wool surrounding the entire building. It gives us something like an R40 wall on this project. You can see the building under construction here. There's a photo from Nastasi Architects as well. During construction, you see the depth or how far back those windows are set. That's the thickness of that continuous exterior insulation. You see the vertical girts over the outside of the insulation, and then the horizontals there, which are going to support the facade. So that greenish material there is that mineral wool insulation. Here's another photo of the construction. This is during construction. You can see the 2 layers of 4-inch mineral wool being installed there, and the clips, those fiberglass facade clips. So those, again, really help us to ensure low levels of thermal bridging, give us that continuous envelope or continuous layer of insulation around the entire building. You can see the detail on the right there, how the building was put together, and that window detail there. So lots of insulation enabled us to meet our heating and cooling targets relatively straightforwardly, even with that difficult backup wall. Now, in terms of the air tightness on the project, we were able to structure things and design the wall in such a way that we could use the weather-resistant barrier as the airtight layer. We found that there was a lot of economy in that. We felt that was a good strategy for a project like this to implement. It would give us the best chance of getting a really good air tightness at a reasonable cost premium. There were some detailing challenges, to be sure. We had to do a little bit of modification when it came to things like window details, door details, and penetrations and the like. Nothing that couldn't be overcome by the construction team though. And one thing that we did get here, which I really like, is that we got a double seal on those windows. So we actually got 2 layers of air tightness, an exterior seal and an interior seal. For the folks who like 2-dimensional drawings, here's a section detail of that window. So here's where the window, here's a head detail of a typical window install. And those of you on the call who are Passive House dorks are probably yelling at me right now saying, Ed, that window's in the wrong place. Any of you who have ever gone through any of our Passive House classes know that we stress put the window out in the insulation layer. That's how you're gonna get the best performance. Well, not on this particular one. Not that we wouldn't have gotten better performance. just that there were lots of reasons having to do with waterproofing and structure that we couldn't put that window out in the insulation layer. So we do the best we can. We overlap it with insulation over the face of the window. We're still able to get a very low psi install value. For those of you who are interested in such numbers, about 0.04 for the heads and jambs on this particular one. We can see we have very good FRSI values as well. So even with the window in a slightly wrong place, we're still getting very good condensation resistance, good thermal comfort, high surface temperatures, and low thermal bridging at those edges there. So even though it's not perfect, it still gets us in a good place. And I like to show this because there's actually a good detail here that I like to show. This was a detail that the cladding team came up with, the cladding manufacturers came up with, John's team and the cladding installer. And I like it very much because one of the things that we often struggle with is how to detail these deeply inset windows. You know, how do you actually attach trim? How do you like physically build a thing like this where you've got 8 inches of continuous exterior? And I like this detail because they were able to figure out a way to attach a back span. So they've got like a little metal angle there, and it's not fastened to the building. It's fastened out at the Z-girts, the vertical and horizontal Z-girts, and then cantilevers back towards the building. Notice it never touches the building, allows us to get good continuous insulation over the face of the window with no thermal bridging, allows the team to install all their trim all the way around in a really reasonable way. I thought it was a really successful detail. And again, this was the cladding manufacturer, installers, and architects team came up with this one. It was a great detail. Worked awesome for us in the end there. These are just some photos of the air tightness going in. I think it's important to stress that this was actually during a mock-up for the window. So one of the things we did with this team was a lot of on-site education and review inspections. This was during a whole window install mock-up where we had the whole installer team as well as the architecture team and our Passivhaus team there on site working through ideas and methods for installing windows. You know, there's a million ways to skin the cat, and we sort of had to work with them very carefully to figure out the best, most buildable, most cost-effective way to install these windows in a way that the installer teams were comfortable with, were happy with, enjoyed, and gave us the performance that we wanted out of this project. You can see here the final install of the building. As I said, we get 2 layers of air tightness on these particular windows. So you can see in the exterior photo on the left, the sort of goop-based seal on the outside. So we have a really high quality weather-resistive barrier with a sealant. As you could imagine from the way that I just described that, I'm not a huge fan of goop-based seals, but that's partly just because I'm really clumsy on the job site. So that goop ends up on my elbow, and then it's on the truck window, and then it's in my hair, and then it's all over the house. And, you know, I personally prefer those air seal tapes, but that's just me. We work with a lot of teams who are perfectly good with the goop-based stuff, and gives you a good weatherproof seal on the outside. That's as per warranty. We're not going to make them do anything different there. And then on the right-hand side, you can see we were able to get that supplemental air seal taping on the inside to make ourselves comfortable. That gives us a really nice, flexible, long-term air barrier. It's going to be resistant to windows slamming and people hanging off the windows and baseballs getting thrown against the windows, you know, all the things that happen to buildings, right? So we got 2 lines of air sealing there, 2 lines of air sealing, which we were really happy with. And then just lastly here, last couple minutes, I just want to show some of the thermal bridge mitigation efforts that we undertook here. Just especially if you haven't seen a type of building like this, using a concrete steel structure to build a building like this to this level of performance. You do have to do a little bit of detailing, which might be quite non-standards, things you haven't seen before. So for instance, the concrete balconies are one place where we really struggled with the thermal bridging issues, both in terms of heat loss, but especially in terms of surface temperatures, mold and moisture resistance. We were able to find a product, and the team was able to successfully install a product which gave us a structural thermal break at those concrete slab balconies. So we still get the architectural benefit and the urban benefit of those exterior spaces on the building, but we get the full thermal break at those balconies. What does that look like in practice? It looks roughly like this. So here's a couple photos from the job site under construction, and you can see those slab edge thermal breaks as they're installed. These get cast in place during the forming of the floor. So as the building is installed, these things is formed, these things get laid in place, the concrete gets poured around them. There's stainless steel rebar that connects to the mat on either side. Again, gives you the benefit of those cantilevered balconies, but with a thermal break. It's not perfect, but boy, it sure makes all the difference when it comes to surface temperatures, mold and moisture resistance, as well as heat loss. This is a photo that I took from standing on that balcony. And when the building was mostly complete, It's an infrared image, obviously, showing red or yellow being warm, blue or dark black being cold. And I'm standing outside on the cold balcony in the wintertime. I open the door, it's nice and warm inside, the building's almost done. And you can see the remarkable effectiveness of that slab edge or balcony edge thermal break. There is very little heat flow flowing through that concrete slab out into the balcony. So a good example of exactly how these things are working in practice. Build the building like a thermos. All the energy that's in stays in. And then just lastly, one detail that I really want to bring up because it was a real head scratcher for us. And so I think maybe other teams might struggle with it. So I just want to share it here. Was the party wall. We had a small chunk up against a neighbor. It was big enough to let a bunch of cold air in, but not big enough to actually put a human in there to build something properly. It's a 6 or 8 inch gap up against the neighbor. Of course, that's very typical for a lot of projects. And this was a real head scratcher for us. We were not sure how to deal with this for the longest time. We sort of iterated through a bunch of different solutions before finally settling on a slab edge product, very similar to those cantilevered balcony thermal breaks, except this one's one-sided. So it actually allowed us to get our thermal isolation up against the neighboring building. And then the design team came up with a solution to build the walls from the inside out. So the installers and John Anastasio's team worked really hard on site to figure out a way to put these walls together, laying down on the ground, and then build the wall from the inside out using a CH stud that allowed them to get both an air seal and a thermal break at the edge without actually having to work from the outside of the building. It was a challenging one, to be sure. It was a weird one that we hadn't run into before, but a totally common one when it comes to urban projects. So I'm sure we'll use this detail again in the future. So with that, again, thank you so much for attending, and I hope I didn't go over too long, and I'd be more than happy to take anyone's questions, obviously, and discuss the project. Happy to answer any questions you might have. As I said, I think Matt Testa is here as well, so he can answer the hard questions.
Thank you, Ed.
That was great.
Just want to remind everyone that's the first of 2 presentations Ed's going to do this evening. He's going to talk about his idea for software jigs a little bit later into the after party. For now, let's take questions for 10 or 15 minutes, then we'll break out into small groups and then come back together.
We've got a lot of questions, so Mark, if you want to start, and we'll go through as many as we can and then dump the rest in the after show. So Mark, you started ourselves off with one. Do you remember it? Mark, are you there? If
I don't think you really want my question this early in the night.
I thought it was a good one just to kick it off, just because I know where you're coming with it. So we like humor.
Ed, my question was the additional bike racks the reason why you were able to achieve Passivhaus on this project?
Yeah, that was what nailed it. That was what put it right over the edge.
Thank you for your extra engineering. That's remarkable. Much respect, brother.
Jeffrey, if you're there, you were next. Go ahead and unmute yourself.
I can't find my question. Can you tell me what my question
is? Yeah, no worries. If that happens, it's okay. That's why I keep track. You had a question about 8 inches of the insulation, how did it get supported against the cladding, the facade?
Right, yeah. So how did that work? I mean, because 8 inches creates quite a difficulty with the weight of the cladding, and I'm wondering how that was overcome.
Yeah. I mean, the facade, as I said, we used a fiberglass clip, so it's a off-the-shelf product that comes at 8 inches. So that was all engineered by the team. The structural team, and in terms of the insulation, it was primarily those vertical and horizontal girts that hold that insulation in place. But it does look like Matt Testa is here, the construction manager for the project. And Matt, do you actually have something that maybe you could speak to that much more intelligently than I actually?
I mean, at the end of the day, those Cascadia clips are pretty well engineered. So we just followed their model as far as spacing quantities are concerned. One interesting anecdote was that we had to fasten them back to the 16 gauge metal studs using 10-inch self-tapping screws, stainless steel screws, which at one point were deemed to be non-existent. but we were too far along in the building process to let that be a fact. So we were able to get them.
So I'm really focused on trying to get passive house costs down. So how much did that add to, from your perspective as the builder, to the construction cost? And could it have been alleviated if it had been discovered earlier in the design process?
Everything's relevant, right? So when I first got the plans for this project, it had a structural glass facade that cost about $200 a square foot. So when I got it down to $100 a square foot, everyone thought I was a hero. However, most facades in New Jersey are $30 a square foot. So long story short, yeah, I mean, it was an expensive building. It was experimental. It was high quality. It was a condominium for sale project. So finishes were top notch, but the sales were top notch too. So
so what, $1,300 a square foot kind of thing, or?
No, we didn't break 350 a square foot construction cost, but we sold it $925. So
yeah.
and the land cost was reasonable. So it was a winner from that perspective, but it's not a testament to how to be the most cost effective with passive house, period.
How early were you as the builder brought into the process?
So I worked for the development team as the general contractor. We're like a vertically integrated team, so I kind of wear a bunch of hats. But we were brought in after municipal approvals, and we were basically given a project that was already approved, but we had a little bit of leeway to make some facade changes, but not volumetric changes. So basically, I had to crunch the numbers without obviously taking any volume out of the building. But we were, it's a scary thing, right? Because, it was my first passive house project. So I don't want to make any value engineering suggestions that might jeopardize the performance. So it was a very delicate process, but we got there, and it was a success. It's a great building. And I learned a lot, and I know what to start with, right? It's all about knowing where to start and how to get a little bit better. This project was kind of walking into a dark room and throwing a dart at the wall, and hopefully it sticks. It worked. It was great. But I think overall, passive house is this awesome process, and it takes everyone to buy in for it to get more viable from a commercial standpoint. So the more and more we all buy in, developers, contractors, architects, suppliers, engineers, then it's going to spread.
Sean, I yield. I have millions of questions.
I know you got to stop.
Everybody else.
You can come back in the after hour. I know those are good ones. But while we're talking about insulation, Todd had a question about that. So Todd, do you want to pop on? I'll give you about 10 seconds and then I'll ask it for you, just because we're talking about. Todd Collins, you still there?
I am. Sorry about that.
No worries. Go ahead and ask.
Modify the mute. No, it was curious. 8 inches of mineral on the exterior. Was it the rigid product, or where'd you get that?
It's the. I think we just used the semi-rigid. Oh, sorry, Matt. You know better than I what the specific.
Yeah, it was the rock wool. So like their rain barrier HD product.
Rain barrier HD product. Cool.
Yeah, typically in BC, you might use the Comfort Board 80, or some single family homes are using the 110.
Yeah, and this would be probably the 4-pound product instead of the 8-pound product.
Yeah.
Still same thermal performance, less density, so it'll squish between the clips, but won't squish like a low density cavity insulation.
Right.
You don't need the higher density where you're not using the insulation to attach furring through it.
Yeah, the higher densities don't come in the 4-inch; they come in only 3-inch. So that's why I was wondering.
Yeah.
And Matt and Ed, while I got you, I've had a lot of private questions asking about HVAC. Do you want to just quickly go over the HVAC on this system, on this project?
Yeah, I focus on the envelope here. Obviously, there's a million more things we could talk about, but very briefly, it's a mini split heat pump system, a split heat pump system with condensers on the roof. Each unit has its own controlled horizontal ducted systems. They do heating, cooling, and dehumidification, all electric. yeah, I'm not sure what else to say about that.
You know,
Good system. Nicely designed system. Had a great mechanical engineering team that helped us with that. I guess the ventilation system were Novus 300s, and the unique part about the ventilation system was that we were pushed early on by the design team to avoid lots and lots of penetrations on the facade. So we had to come up with a shaftway strategy that allowed us to tie in the core of the building, and that was a real challenge. That was one that we had never done before. So that was a new one for everybody. But it did avoid a whole bunch of gnarly penetrations on the facade and allowed us to join those together into just a few penetrations up at the roof. And again, that was mostly the mechanical engineering team that was able to make that work through their design, which was awesome.
I was really fascinated by that shaft system. As far as I know, you're one of the very few projects to pull off small HRVs all pulling through an intake shaft and exhausting through an outtake shaft in a larger building.
It was a weird meeting. We were meeting with the HVAC guys and we were going through a whole bunch of stuff and they said, oh no, we'll just do it this way. We'll just do it with this. And everybody, and I remember me and John, my partner, were sitting there and we were sort of like, oh, really? You're going to do that? Okay, sure. We were thrilled by it. It was not something we had ever imagined was sort of feasible. It was a new one by us.
Where are we here in the question? Sorry, there's been lots going on. Nazir, you had a question. Sorry, I'm going to put you on the spot just because I just got back to my list here. Nazir Khan? No, I will move on.
Yeah,
go ahead.
How much energy saving is there from natural light?
That's a great question. I don't have a good answer for that. I don't have a quantification of that right in my back pocket. It's a challenging project because it's one-sided. We had one long party wall that we could not get any windows on. So it's obviously a lot line on one side. And so it's in many rooms, it's one-sided daylighting. There are some nice spaces where it's two-sided, but I think John Nastasi and his design team did a really nice job balancing that challenge. Given that challenge, they were still able to make some really nicely daylit spaces, but I don't have a good quantification for that. It's a great question. Given that it's residential, my guess is that the lighting reductions are not enormous. Electric lighting is not an enormous load on most residences that we work on. If it was a commercial office building, obviously it'd be a different situation. So my guess is that it's not enormous, but I don't have a good number for you. Great question.
Ayo, you got a question?
Yes, a couple of questions actually, if I may.
Oh, you can get one, and then you got to come back in the line. There's a long list tonight.
Really? Okay, I'll fix the party wall then. I was kind of curious, and I may have missed it, what the buildup was of the party wall.
For along the western side, along the core. Yeah, so that's a good question. I did not show that. That was actually an EIFS or an EIFS application. So that was a cast concrete wall, which was the core, of the building, the elevator shaft and the fire core of the building, and then we did an exterior insulation and stucco finish. A synthetic stucco finish on that as well. That, like I said, is a party wall, a lot line wall there on the western side.
Very cool, thanks.
Sure.
Actually, hey, I'll let you do the second one because I just missed my lister. So go ahead and ask your second one.
Perfect.
I'll keep the next one.
Lucky.
Yeah, you're lucky.
I was just wondering the product that you guys use. Maybe you didn't mention it because that might be, against your professionalism. But the product for that thermal bridge mitigation on the concrete slabs is.
It's a good question. That was a company named Shock.
Okay,
it was a French company. So that was the product that we used there. And yeah, they were really helpful coming up with some good solutions for a couple different spots.
Right, yeah, I've seen that product. I figured that was what it was. Thank you.
Sure.
All right, Peter Moonen.
Thanks, Sean. And thanks for showing us your project. And it raised the question, I noticed that the building in Hoboken is concrete. Would you be permitted to use heavier mass timber in a building that size in future? Because that would have probably saved you a few difficulties with respect to thermal performance and insulation. And with respect to that zero clearance on the wall against the other building, there's a project like that going on in North Vancouver. Sean, you may know about it with Nate Kuhn. that has a zero clearance, and they're putting in a passive prefabricated pre-cladded wall in this office restaurant building, and it'll be passive house as well.
It's such a good question, right? I mean, so as I said, this project was begun in 2013, and I'll admit, embodied carbonate materials wasn't even on my radar back then. I mean, we were working on passive house, we were struggling against just implementing any sort of passive house improvement, and it just wasn't even sort of a thing in the back of my mind. There's a lot of things we would probably look at differently if we were to start a project like this today. That said, I doubt it. I have never seen a project of 7 stories in the New York metro region that's able to use mass timber in that fashion, but I'm not an expert on that. So if anybody on the call knows differently than I, go ahead, feel free to chime in. I've seen 4 stories. I've never seen 7 stories out of mass timber. So New York metro region, I don't know, but I've never seen it.
I'll be in touch because there are a couple of projects that were underway. I don't know whether they're still going forward, but one is an 8-story.
You know, there's been great people like Stas Jasewski and his team at ZH. You know, they've been working on it and picking at it for years. I don't know how much progress they've made. You know, there's really talented, really smart folks in New York that are working on it. And I think it would be amazing. I mean, like you say, it would make our life so much easier on the thermal bridging. Yeah, I've never seen anybody do it. And I don't know enough about the codes and the limits there, I have to admit. I'm not sure.
So Ed, 2021, the code's changing. So there's going to be 3 different mass timber qualifications. I think it's 6-story, 9-story, and 12-story, I believe, where it's all about compartmentalization of fire stopping.
Oh.
I think the max is 18.
18, okay, yeah. So 2021, it'll be a conversation, but I from what I hear, it's going to be local building code driven as far as the adoption is concerned. I have heard of some people having conversations early before the code actually goes into place to see if they can get some plan reviews going so that when buildings are ready for shovel after 2021, they're good to go. But it's in the works. It's moving in that direction.
And Ed, I think Jeff Spiritos, who's a mass timber guy, is somewhere on the on this thing too. So he's in New York, so you might want to reach out to him, Jeff.
Awesome.
Yeah.
Oh,
and
thanks.
Right.
Peter,
Thanks, guys. Oh, go ahead, Pete. Jeff, go quick.
oh, thanks. We've got 3 passive house mass timber projects in late stages of design in case anybody wants to talk about that.
Yeah, stick around, Jeff, for the after hours because you know, I definitely want to. Again, we're gonna jump into Zach quickly, but Alan, I'm gonna let you have the final question because I'm sure Ed will appreciate it. Alan, you there?
Sure. Thanks, Sean.
Yeah, far away.
Hey, Ed. Great presentation. I should probably know this because after 2 years, you have to jump to expert. So I can't remember exactly did you run the numbers assuming that it's possible, whether it's allowed in current zoning or not, that the buildings adjacent to you could have extended higher and as they do and block the sun and therefore change some of your solar gain calculations?
Yeah, no, that's a really good point. That's a really good point. Yeah, for sure. We always look at those things in an urban area like Hoboken that's rapidly developing. You're going to see that. They're probably not going to get too much taller than us. The zoning requirements there are pretty strict, but they could certainly match the height of the building. In any event, this building had almost no useful solar gain in terms of the overall heating energy. It was north and east facing. The south face of the building was up against another building already that was almost the same height as the building. And so we were at quite a disadvantage from the beginning there in terms of solar. So we really didn't have a lot to lose, to be honest, as the neighborhood builds up around. If anything, we could probably drop the cooling a little bit if we got some shade to the east, if we limited some of that early morning sun. But yes, we look really carefully at the shading. It's such an important part, especially when it comes to overheating risk in a place like New York. So we look really, really carefully at the shading condition in all sorts of different ways. So great, yeah, totally, good point.
Okay, I think we're going to jump into the breakout rooms. Yeah, Sean? Great.
Yeah, absolutely.
So we'll have 6 minutes for these, and we'll have more time for Q&A with Ed in the after hour. So start with rapid fire introductions, and then share, what stuck out to you today for the presentations, or if you're a newbie, feel free to ask any question. So here we go. All right, I think we're all back. So hopefully you had a nice breakout session, and thank you. We're very excited about next week to have Graham Irwin, who is a regular on the happy hour and quite the Passivhaus troublemaker based in California. He'll be presenting next week, so don't miss it. And with that, I'll hand it off to, I think, Andy, who's going to do a quick intro to the community forum page so you guys know about that.
Where is the real Andy?
Andy is muted.
I see his.
Okay, sorry, I'm here.
There he is.
Okay.
You get an okay boomer for that one.
I love that.
Sorry about that. Okay, so if you go to passivhausaccelerator.com, there's a link on top called Q&A community. It is a question and answer community for all things Passivhaus. If you register for an account, it's 100% free. And at the moment, we have a little over 175 members, and we have about 200 questions and answers already posted. We quietly launched this a little over a month ago, and it would be great if I could get around 250 questions before we publicly launch. And so here's an example of a question. I just typed in which Passivhaus window companies are approved by landmarks and historic buildings in NYC. And it's really that easy. You can ask literally any question related to Passivhaus on your project, and you can tap into a global community of experts. That's pretty much it. Thanks, guys.
Thank you, Andy. Thank you also to Ed and to Sean for that great video. It's been great having both of you on today.
So I'm curious, how do we get a reputable user rating as good as Adam Cohen? Seems a bit mystifying.
You have to answer a lot of questions. If you answer questions and interact with people, your rating goes up.
Okay, got it. Okay, fair enough. Thank you.
I think it's
scary thing. I know Adam Cohen.
I know. Describing Adam Cohen as the most reputable person on the site, does raise interesting questions.
Sure.
All right.
In a loving
He's
way.
retired, so he has lots of time to answer questions. The rest of us are not retired. Yeah.
It's all about that mustache, that really trustworthy mustache he's got going on.
Mark Twain.
Yes, and the wax to go with it.
It's simple. He looks like like Tony Stark, and he's brilliant like him. That's it.
Okay, well, on that Tony Stark note, thanks everybody. I think we'll let Sean roll us into the after party. If those of you who need to move on with the evening, feel free. If you want to stick around for the after party, I think Ed's going to present a little more, and we'll have some more questions and answers.
Yes, again, I know everyone has time, so if you do need to sneak away, please do so. But if you have another half an hour, and again, you can tell other people to give you half an hour, you want to stick around for this after hour because Ed's going to talk about jigs. And, for the 9 weeks I've been doing the Passivhaus after hours, I think this one's going to be the best one. I don't mean to give Ed any pressure, but that being said, Ed, why don't you just take over and take the wheel and dive into things?